Well, good morning, everyone. It's morning when I'm recording this anyway, whatever time it is when you're watching this video. But what we're going to do on this video is I want to create a new project. One of the first things that you will do after you do the previous video, which is establishing communications. So what I'm going to do here real quick is go ahead and start RS links from before, just to make sure we are communicating. And here you see the USB driver, RS links classic gateway, and I will expand that. And I can already tell I'm communicating because I've got the USB driver. But if I, and I'll do this like it would normally be, I will see my processor and the project that's in the PLC right now. And I will expand that and I will see the point IO. So if I click on that, I'll see it over here. So here's the processor itself. You look at my arrow that I'm using to point to. The next one is the 24 volt, 16 point DC input and 16 point DC output that is built into the PLC. And then after that, I see the 3 expansion modules on the right hand side of your trainer. First one again being the 4-channel current input, analog input, the 2-channel current analog output, and the 4-channel thermocouple input. So we haven't defined that. We're not going to use these 3 expansion modules yet, but we will soon. So I'm communicating. I am going to minimize this, and I'm going up here where you see an icon labeled Studio 5000, which is the programming software. And I will double click that. And I'm going to create a brand new project right here. That's what you will do. New project. You will pick your processor, and it should come up with the processor that you're using by default. Just highlight it, which is a 1769 L16 ERBB1B. Basically what that part number means is the particular compact logic controller 5370 that you're using, and here the part number means that the 16 is the 16 input and output, and the BB1B means that it's 24 volt input and 24 volt output. So I must give everything a name in Studio 5000. So I'm going to call it EETC 2331, which is our course. PLC in space, if you notice, puts an underline in it because it don't really want spaces. So it does that for you. I'm going to put day, meaning day class. If you're in an evening class, you would put EVE, space, station 0, which is the one that I'm connected to, or going to be connected to, and that will actually be the next video when I do that, when I actually download it and so forth. This video is to create an offline project. So with that said, if that looks good, I'm going to say next right down here, and make sure that yours says version 30. If not, choose it. In this case, that's the only choice I have, and I must put down the number of expansion modules. If I don't do that or don't do it correctly, it will cause the processor to error on us. It'll fault the processor. So I got 3 modules. Next thing, do not put any protection in it. Do not do that. You will cause us great grief and stress. So no protection. And then I will come over here in the lower right hand corner and click finish. Now what's happening now is it's going to start the new project. You'll see the Studio 5000 splash screen come up, and it'll take several seconds for this to finish. And what you see now, when it finishes, it's still loading. You will see the beginning screen. So it'll get there in just a minute. There we go. Now, what you see, first of all, on the left-hand side is what's called the controller organizer. In some software programs, that's called the project tree. But nevertheless, this is where we choose many of the functions that we're going to use. We're not going to use everything over here in this class, but we will use quite a few things. Up here on the left-hand side, you see a mimic of the lights that's on the Compact Logic processor. Right now, we're offline, so there are no lights. Over here on the right, you see a list of all the instructions. Now, they're grayed out right now, which means we're not in the mode to start editing or putting in ladder logic. In this video, we will put no ladder logic. The purpose of this creating the new project is to create one that will run on the PLC, but it will not do anything. And that's what we want to do at first, because this project that you're going to create is going to be one that there is no ladder logic, so that we can do what we call I/O checks. That's one of our upcoming videos when we actually check out the I/O on the hardware that we have. So right now, just leave it as that, and we'll get started. Now, right up here, we have what's called a task, or the task, a main task, main program. And if I expand main program, I'll see main routine. Main routine is the routine that is created for you automatically. I can rename it somewhere here, rename, when I get ready to. It's not showing me that. Anyway, if I click on main routine, double click on it with my left mouse key, I will see the main routine. Now, it gives me a starting rung of logic. That's what this means. This is a rung of logic with the left power rail and the right power rail. So it looks like, or as you create it, it'll look like a ladder. That's why they call it ladder logic. But I don't want this at all to begin with. And I'm just going to hit the delete key on the keyboard to get rid of it. And there it's gone. What you see is the end rung, which every routine that you put into this PLC will have a end rung. That means I have reached the end of the routine, and it will either go back to the top and start scanning again, or it will jump to another routine if you have that instruction in there. But we're getting ahead, so just it will look like this. Now, if I go up here to the top left, and what it shows here is the project that's that I just told it to create. But right under that, if I look at controller tags, it will see the cryptic controller tags I have for the 16 inputs and 16 outputs. And the way I know this, if I expand the local 1:I, then I will see two words, and I'll explain more about words of memory shortly, but I will see a data word. The data word is the 16 inputs that is built into the processor that I showed you in I think the second video that we did. And in Allen Bradley world, and this is true in Siemens world too, that they start numbering everything from the number 0. So 16 inputs are numbered 0 through 15. Now, we will also attach some tags eventually to this so that you can forget this cryptic address. But for now, we will use that to get ready to do the I/O checks. On the output side, we can do the same thing and expand its data word and see the 16 outputs. So there is the 16 inputs, 16 outputs for the digital discrete I/O that's built into the processor. So we will use that in the very near future. Okay, with that said, I'm going to deem this a beginning correct project. Now down here you'll see where it says the embedded I/O and the 3 expansion modules that we defined when we first told it to create the project. So back to the main routine, nothing in it, and that's what we want for now. We will start looking at what these different tags are to start adding ladder logic to actually do something. But for now, this project will allow us to do I/O checks. I/O checks are done to make sure that the inputs and the outputs are connected correctly to the pendant on to the left of the processor that has the push buttons and switches, and also the piece of Festo equipment that I showed you in the very first video, and so that we can actually check those out. If the inputs and outputs are not connected properly, or they are not functioning, then we can't really start writing a functional program until we get that checked out and make sure it's okay. I will be giving you an I/O checklist. It'll be a paper printed lab that you can use to do this. So, but this video is to how just to create a good project and get it running in the PLC. So what I'm going to show you, I'm going to go up, I'm going to deem this correct. I'm going up to communications up at the top, and I will say who active. And what that means is it's going to look and see, who am I connected to? Well, as I said before, you're connected USB. And if I expand this on down, I will see all the I/O and so forth. If I click back on the processor, which is right here, I should get these to highlight over here, and I can do a download. Now, I told you this was a valid PLC, so I'm going to do that. I'm going to download this to the PLC that I am connected to. Now, what it's going to do to begin with, it's going to ask me if I want to download. Now, you can't see it on the processor right now, but these lights up here, notice that they have turned colors. And it's telling me that the PLC is in run mode, the controller is okay, and the I/O is okay. Green is good. So that means that everything on the PLC looks good right now. And when I go to do a download, it's going to start downloading. But did you notice that the program mode, it went into program mode, went out of run mode? Now, it's already through downloading, so does it ask if I want to go back in the remote mode, and I will say yes. When I do that, the green light comes on, and it is now running the project that you created. And right up here is the name of the project. This allows us to do I/O checks. Now, this is going to end this video for now, but we're going to get ready to do I/O checks. So, goodbye for now, and I hope this video was meaningful to you. May have to watch it multiple times, but anyway, thank you for watching it.